Okay, this is a lesson for chapter 4, lesson 5. And we have two parts because we have two types of functions. We're supposed to do sequences and functions. So what are the two types of sequences we have? Arithmetic and geometric. Fantastic. So we're going to be having to change these arithmetic forms into function forms. So I want you to look at what they did here. And specifically, I want you to look at this step, then this step, and then down to that step. What did they do on those green steps? What did they do from this one to that one? They distributed. So our step 1 on these things, if we were to make notes about what to do, step 1 is to distribute. Step 2, what did they do from this green line down to that green line? Simplify / combine like terms. So simplify, combine, well, let me write the actual word, combine. And then step 3 would be to graph it. Oops. And I prefer just using my graphing calculator to use to get a table if I need to. It's basically whatever you want to do. So let's try that on we're actually going to try it on a weird one for the sake of, actually let's just try it on number 2. So what do we have to do first? Distribute what?
15 to n.
So 15 to those two. So we're going to still have, and then we're going to change this part to f of n.
We're pretty much doing the same thing.
Yeah, it's just that you're simplifying the function first. Pretty much doing the same thing, but simplifying it. What is 15 times n? 15n. And then 15 times negative 1? Negative 15. And then final answer for this thing, f of n is equal to what? What is negative?
65.
Yeah, negative 6. So, but then we want it in the mx plus b form, because our goal is to put it in mx plus b form.
15n.
So it's going to be 15n minus 65. And then you can graph from there. You can graph it in lots of different ways. You're still supposed to do the increments and what it says right here between 1 and 10. So we can still do the same type of thing like they did above. So across here, we would still have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then, knowing what we know, where is this graph supposed to start? Negative 65. And then is it going to go up from there or down from there? Up. So if I make this bottom one negative 65, how much should we make each one go up by so it makes it really easy? 15. And how did you get 15?
Because it goes up.
Yeah, because they go up by 15. So this is going to be negative 50, negative 35, negative 20, negative 5, up to 10. Then what? 25. Then what? 40. Then 55 and 70. Okay. So then the cool thing is about so this starts right here, right? And then over 1 up 15 because that's my slope, right? Or over 50, yeah, up 15 over 1, and it's just going to be a nice perfect diagonal across the graph. Easy, huh?
Yeah.
So arrow, arrow, this will be the x-axis and that's the y-axis, even though technically it should be, this is the n-axis, and then this is the f of n-axis.
Thing be at between negative 5 and 10.
Should the axis thing between, oh, yes, should the x-axis be between negative 5 and 10? Yes.
Jumps.
And so I'm just going to move that. I'm still going to keep the numbers down here because technically it doesn't matter. So that'll be the end. Bravo. Okay. And that's all you do for these. So that's going to be what you do for numbers 1 through 6. Let me do a weird looking one because it's fractions and people pee their pants when they see this. Not really. My room does not smell like pee. Okay. So we're going to do the same types of things. We're going to distribute and then we're going to combine. And notice that these are horrible because they're fractions. So I'm going to do something really wild, and I'm going to change this fraction into a decimal. What is it?
Negative 0.6.
Negative 0.6. Okay. So then, we would have f of n is equal to 3 plus, and then what is negative 0.6 times n?
-0.6.
Negative 0.6 n. And negative 6 times by negative 1. Negative times negative is a positive, and then it's going to be 0.6. Feeling okay with this? Now what's the last step?
F is, you add like terms.
Those two. All right, so it's going to be negative 0.6 n, and which we actually might want to switch that back to a fraction for the sake of graphing, because it actually makes it pretty easy. And then plus 3.6, right? Because 3 plus 0.6 is 3.6. Feeling pretty good with that? Okay, and then I'm going to change it back to negative 3/5 n, and I'm still going to keep it 3.6 because it's easier for my brain. Okay. Or actually, you know what? I'm going to leave it like it is. Sorry, changed my mind. I should go back and edit. So you get to this thing. So then, where is this graph going to start? Okay, and then what is it going to do after that? Go up or go down? Down. And how can you tell? So since that's a negative, it's going to go down from there. So then this needs to be my biggest y. So I'm going to put 3.6 at the top. And then how far does it go down by? 0.6. So this will be 3. And then that will be 2.4. And then 1.8, right? 1.2, 0.6, 0. Hey, look, we have a normal x-axis. How nice. In fact, we're going to call it the n-axis. And then negative 0.6, negative 1.2, negative 1.8, negative 2.4. Feeling good? Okay, so where does it start again on the y-axis? So it's going to start at 3.6, and then it's going to go down 1.6 and over 1. And so we could actually label these. And then it's just going to go diagonal across the graph. Oops. Dun, da, 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 dun, 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 dun. Feeling good? Pretty easy, yeah? Okay, good. And so that's it for 1 through 6. And I'm going to give you some time on that, and then we'll go on to the 7 through 12. Only skip one in the section. Okay, so this next part is the geometric sequences. This is numbers 7 through 12 on 4.5. And I want you to look at what they did. So they put the f of n, and then look at how they did 2 to the n and the negative 1, they like split it. Do you guys see how they just kind of split it?
Yeah.
It's kind of like distributing it-ish. But then they rewrote them. And what is 2? What is anything to the negative 1? What does that negative 1 do to it? It flips it, right? So it's 1 over 2. And then when you do 5 times by 1 over 2, it's 5/2. So the shortcut version to this is you're going to take the first number, and that goes on top. The number that's right here goes on bottom. And then times by this number, just this part, 2 to the n. And then, so that would be the
Why
function.
didn't they just do that before?
Huh?
Why didn't they just do that?
What do you mean, why didn't they do that before? They explain why.
Trying to figure that out right before we did this lesson.
Uh-huh. He tried figuring it out, and it's tough. And you know what? And I've taught it so many different ways, and I have tried to teach it this way, but people are like, and crying, and that's really sad. And so then I decided not to teach it that way. So let's do, so like number 12, see how the first, now, so we're going to put f of x, or f of n. F of n, so the first number goes right here. The thing that's being put to the power goes underneath, and then times by 1.25 to the n. Then use your calculator. What is 1250 divided by 1.25? 1,250 divided by 1.25.
It's 1,000.
Good, 1,000. So our final thing for this is f of n is equal to 1,000 times by 1.25 to the n. And then you're going to graph it. So you're going to graph it. You can use the same techniques that we learned last time, like with the last thing. You can use the table if you want to. So 1,000 times by 1.25 to the x. I don't like doing that because then it always messes things up. See, and it's thinking,
Hey, wait,
and you
how
can't
do
really
how do
see
you
it.
graph it?
Hold on. Okay, so this is how I like to graph it. I like to go to the table first because I know from my experience that the table makes things nice. It says you're supposed to go between 1 and 10. So, table. So what's my biggest number on the table?
1,000. No, not yet.
Yeah, 1,250. That's the smallest one, right?
Sure. Yeah.
And then what's the largest one?
9,000.
9,000, right? So 9,000 something. So what do we want to rearrange it to be? So like,
1,000.
if I just made the top thing 10,000, do you see how I can really easily split that into 10?
Yes.
So then it's just going to go by 1,000. So 9,000, 8,000. And then I know that the x-axis should just go 1, 2, 3, 4, 5, 6. Okay, feeling pretty good with this? So I always look at the table to guide me to be able to figure out my window. And if you want to, at this point, what you could do, because are we supposed to graph them as dots? Did they graph them as dots? They did. Okay, so then you can just graph those dots, but I kind of like to double check that I'm graphing things right. And how I do that is I look at my window. So I go to my calculator, however you go to window, I'm gonna change and make sure my window matches this. My X is, what's my X minimum?
0.
X max?
10.
So do I need to do anything to mine? No. What's my Y minimum?
1,000.
0. And my Y max? 10,000. And how often did we put those numbers? How often? 1,000. So I'm going to do that and then just push graph. If yours doesn't graph, chances are the plot is on. So I know that this is what it's going to look like, but I still want to be a little bit more accurate. So see how this isn't so much of a steep swoosh, it's kind of like stretched out swoosh. Do you see what I'm saying? So I'm gonna go back to the table, and then 1 goes with 1,250, then 1,500's about halfway in between, then 1,900's a little bit under 2,000, then that's almost halfway in between, then 3,000, and 3,800 something, and 4,700 something, almost 6,000, 74,000, and then 9,300 something. Okay, so I just followed the graph, but would you guys agree that this looks really pretty and close to our graph? Yeah, okay. So that's all you're doing is just, I would use the table to help guide you. Watch where you're putting the x-axis, and then that's it. Okay, feeling okay with this? So you get to skip 1 in that section, and that is the end of the 4.5 and the end of chapter 4. You get to skip 1 in 7 through 12 and 1 in 1 through 6.